7-5 complex numbers in polar form, De Moivre's theorem, day 2. Our learning goal is the same, that you'll be able to represent complex numbers and their operations on a complex plane. So in this lesson, we're going to learn how to write the complex number in polar form and then change polar form to rectangular. So let's first go over what a rectangular form would look like. Okay, so rectangular form is known as Z equals A plus BI. And then the absolute value is R. So to go to polar form is Z equals R times cosine theta plus I sine of theta. And it says where A equals, so here's the formula to help you find A, R times cosine theta, B equals R times sine theta, and then of course R is our A square root of A squared plus B squared. And just remember, tangent of A is B over A. The value of R is called the modulus, which is in plural is moduli of the complex number, Z. And the angle theta is called the argument of the complex number, Z. So theta is the argument and R is your modulus. Okay? So make sure you have those formulas so we can try a couple problems. Okay, so we're going to plot, for example 1, we're going to plot the complex number, and then we're going to write the complex number in polar form. Alright, so first thing we're going to do is plot the point. Remember, label your axes. Imaginary. And here's real. So I'm going to go 2 to the right and then 2 down. So there's my point. And now I'm going to write it in polar form. First thing we need to do is go over the formula. Z equals R cosine theta plus I sine theta. First thing we need to do is find R. Remember, R is square root of A squared. So A is 2, B is negative 2, plus negative 2 squared. So that's 4 plus 4, which equals square root of 8, which is 2 square root of 2. Okay? And then we're going to find theta. And you're going to do that by tangent of theta equals B over A. It's kind of like we did before, the y over x, negative 1. And in this quadrant, we have to figure out which angle has a tangent value of negative 1. So we have 5 pi over 3, 7 pi over 4, and 11 pi over 6. Well, the only one that has a tangent of negative 1 would be this middle one. So my theta is 7 pi over 4. So then to write it in polar form, is Z equals R cosine theta is 7 pi over 4 plus I sine of theta, which is 7 pi over 4. And you're done. Okay, example 2, now we're going to write the complex number or polar number in rectangular form. So now we're going to this form, z equals a plus bi. Okay, for example A, we're given that r is 12 and theta is 60 degrees. So what we're going to do is we're going to find the exact value of cosine of 60 and sine of 60. Remember the coordinates for 60 are 1/2 and radical 3 over 2. This is cosine, this is sine. So to find the value, you're going to do 12 times cosine of 60, which is 1/2, plus I times sine of 60, which is radical 3 over 2. And then I'm just going to distribute. I'll get 6 plus I 12 times radical 3 over 2. Well, this divides evenly to 6. So my final answer would be 6 plus 6I radical 3. Part B. Now my r is 7 and theta is 3 pi over 2. The coordinates for 3 pi over 2 are 0 and -1. This is cosine, this is sine. So plugging in those exact values, I'm going to get 7 times cosine 3 pi over 2, which is 0, plus I times sine of 3 pi over 2, which is -1. I'm going to distribute the 7, and I get 0 minus 7i, which just gives me -7i. And that's it.